Good morning to one and all. My name is Sheikh Mohammed Iqbal and I am from 3CSCD. Today I am going to give a seminar topic in DWM data mining about the topic data pre-processing in data mining. So let us discuss about the pre-processing. Data pre-processing is an important step in data mining process. It refers to the cleaning, transforming and integrating of data in order to make it ready for analysis. The goal of data preprocessing is to improve the quality of the data to make it more suitable for the specific data mining tasks. Some reasons, common steps in the data preprocessing include data preprocessing is an important step in the data mining process that involves cleaning and transforming raw data to make it suitable for analysis. Some common steps in data preprocessing includes data cleaning. This involves identifying and correcting errors or inconsistencies in the data, such as missing values, outlier, and duplicates. Various techniques can be used for data cleaning, such as imputation, removal, and transformation. Data integration. This involves combining data from multiple sources to create a unified data set. Data integration can be challenging as it requires handling data with different formats and structures and semantics. With different formats and semantics, techniques such as record linkage and the data fusion can be used for the data integration. Data transformation. This involves converting the data into a suitable format for analysis. Common techniques used in data transformation include normalization, standardization, and discretization. Normalization is used to scale the data to a common range, while standardization is used to transform the data to have zero mean and unit variance. Discretization is used to convert continuous data into discrete categories. Data reduction. This involves reducing the size of dataset while preserving the important information. Data reducing can be achieved through techniques such as feature selection and feature extraction. Feature selection involves selecting a subset of relevant features from the dataset, while feature extraction involves transforming the data into a lower dimensional space while preserving the important information. Data discretization. This involves dividing continuous data into discrete categories or intervals. Discretization is often used in data mining and machine learning algorithms that require categorical data. Discretization can be achieved through techniques such as equal bit binning, equal frequency binning, and clustering. Data normalization. This involves scaling the data to a common range such as between 0 and 1, -1 and 1. Normalization is often used to handle the data with different units and scales. Common normalization techniques include min-max normalization, z-score normalization, and decimal scaling. Data preprocessing plays a crucial role in ensuring that quality of data, the accuracy of the analysis results, the specific steps involved in the data processing vary depending on the nature of the data and analysis goals. By performing these steps, the data mining process becomes more efficient and the result becomes more accurate. Pre-processing in data mining. Data pre-process data mining technique which is used to transform the raw data into useful and efficient format. Here we have given a flowchart about the data pre-processing. The data pre-processing can be subdivided into four or three processes: data cleaning, data transformation, and data reduction. Data cleaning is further divided into missing data, ignoring, and it is achieved by ignoring the tuples, fill the missing values with manually by mean or by most probable values. Second is noisy data, removing the noisy data by binning method, regression, and clustering. Data transformation, normalization, attribute selection, discretization, concept hierarchy generation. Data reduction, data cube aggregation, attribute subset selection, numericity reduction, dimensity reduction. So let us discuss about the topics separately. So steps involved in the data pre-processing. Data cleaning. The data may have many irrelevant and missing parts. To handle this part, data cleaning is done. It has it can be achieved in two steps. Here we can achieve the data cleaning is a crucial process in data mining. It carries an important part in the building of a model. Data cleaning can be regarded as a process needed, but everyone often neglects it. Data quality is the main issue in quality information management. Data quality problem occurs anywhere in the information system. These problems are solved by data cleaning. Data cleaning is fixing or removing incorrect, corrupted, incorrectly formatted, duplicate, or incomplete data with a data set. If data is correct, outcomes and algorithms are unreliable, even though they may look correct. When combining multiple data sources, there are many opportunities for data to be duplicated or misleaded. Generally, data cleaning reduces errors and improves data quality. Correcting errors in the data and eliminating bad records can be time consuming and tedious process, but it cannot be ignored. Data mining is a key technique for data cleaning. Data mining is a technique for discovering interesting information in a data quality mining. In a recent approach applying data mining techniques to identify and recover data quality problems in large database, data mining automatically extracts hidden and intrinsic information from the collections of data. Data mining has various techniques that are suitable for data cleaning. So steps of data cleaning. While the techniques used for data cleaning may vary according to the types of data your company stores, you can follow these basic steps to cleaning your data, such as remove duplicates or irrelevant observations. Remove unwanted observations from your dataset, including data observations or irrelevant observations. Duplicate observations will happen most often during data collection. When you combine datasets from multiple places, scrape data or receive data from clients or multiple departments, there are opportunities to create duplicate data. Deduplication is one of the largest area to consider in the process. Irrelevant observations are when you notice observations that do not fit in the specific problem you are trying to analyze. For example, you want to analyze data regarding millennial customers, but your data set includes older generations. You might remove these irrelevant observations. This can make analysis more efficient, minimize distraction from your primary target, and create a more manageable and performable data set. Filter unwanted outliers. Often there will be one of observations where at a glance they do not appear to fit within the data you are analyzing. If you have a legitimate reason to remove an outlier, like improper data entry, doing so will help the performance of the data you are working with. However, sometimes the appearance of an outlier will prove a theory you are working on, and just because an outlier exists doesn't mean it incorrect. This step is needed to determine the validity of the number. If an outlier proves to be irrelevant for analysis or is a mistake, consider removing it. Handling missing data. You can ignore missing data because many algorithms will not accept missing values. There are a couple ways to deal with missing data, neither is optimal. But both can be considered, such as you can drop observations with missing values, but this value drop or loss information, so be careful before removing it. You can input missing values based on the observations. Again, there is an opportunity to lose the integrity of the data because you may be operating from assumptions and do not actually observations. You might alter how the data is used to navigate null values. There are many methods through which the data should be run. The methods are described below. Clustering, ignoring the tuples, filling the missing values, binning, regressions. Ignoring the tuples, the method is not feasible as it is only comes to use when the tuple has several attributes is has missing. Filling the missing values. This approach is also not very effective or feasible. Moreover, it can be time consuming method. In approach, one has to fill the missing value. This is usually done manually, but it can be also done by attribute, mean, or using the most probable value. Binning method. This approach is very simple to understand. The smoothing of the sorted data is done using the values around it. The data is then divided into several segments of equal size. After that, the different methods are executed to complete the task. Regression. The data is made smooth with the help of the regression function. The regression can be linear or multilinear regression. Has only one independent variable, and multiple regression has more than one independent variable. Clustering. This method only operates on the group. Clustering groups the data in a cluster. Then the outlier are detected with the help of the clustering. Next, the similar values then arranged into a group of a cluster. So let us move to the next, data transformation. This step is taken in order to transform the data appropriate form suitable for mining process. This involves the following ways. Normalization. It is done to in order to scale the data values in a specified range -1 to 1 or 0 to 1. Attribute selection. In this strategy, new attributes are constructed from the given set of attributes to help the mining process. Discretization. This is done to replace the raw values of the numeric attributes by interval levels or conceptual levels. Concept of hierarchy generation. Here, attributes are converted from lower level to higher level in hierarchy. For example, the attribute city can be converted to country. Next, data reduction. Data reduction is a crucial step. It is the step in the data mining process that involves reducing the data set while preserving the important information. This is done to improve the efficiency of the data analysis and to avoid overfitting the model. Some common steps involved in the data reduction are feature selection. This involves selecting a subset of relevant features from the data set. Feature selection is often performed to remove the irrelevant or redundant features from the dataset. It can be done using various techniques such as correlation analysis, mutual information, and principal component analysis. Feature extraction. This involves transforming the data into a lower dimensional space while preserving the important information. Feature extraction is often used when the original features are high dimensional and complete. It can be done using the techniques such as PCA. Linear discriminant analysis and the non-negative matrix factorization. Sampling. This involves selecting a subset of data points from the dataset. Sampling is often used to reduce the size of the dataset while preserving the important information. It can be done using the techniques such as random sampling, stratified sampling, and systematic sampling. Clustering. This involves grouping similar data points together into clusters. Cluster is often used to reduce the size of the dataset by replacing the data points with a representative centroid. It can be done using the techniques such as k-means, hierarchical clustering, or density-based clustering. Compression. This involves compressing the dataset while preserving the important information. Compression is often used to reduce the size of the dataset for storage and transmission purposes. It can be done using techniques such as wavelet compression, JPG compression, and GZIP compression. So thanking you for giving me this opportunity.